Okay, this is the Unit 3 Activity 7 practice assignment answer. For the first question, Bill is trying to collect all 150 of the original Pokemon cards. So he began collecting them because his brother bought him 40 cards. So I just kind of summarized this. So the total cards he wants to get is 150. He currently owns 40, so he's already starting off with 40. So the 40 is kind of like his initial value, if we're kind of relating this to a linear relation situation. And his parents are giving him enough money that he can buy 3 cards every week. So to me, that's like the rate of change or the slope. So that's what the graph would be going up by every week. Rate of change or slope. So if I wanted to write an equation of this to represent this situation, you can use y's or x's or c's or d, like any variable you want. So let's say I wanted to say, let's let w represent weeks, and let's let C represent the cards, the Pokemon cards. So then if I wanted to write this as an equation, I would say that C, the total number of cards. Yeah, maybe I should write it like that. Oh, that would be better to say. That will let C represent the number of cards. That would sound better. Okay, so the number of cards, so C is equal to 3W plus 40. So I would say if I just said C equals 40, that's how many cards he has now. But then I'm adding in this 3W because he's going to get 3 every single week. And we can test out our theory by subbing stuff in. So we could say, well, after week 1, how many cards would he have? Okay, so 3 times 1 plus 40. 3 times 1 is 3, and 3 plus 40 is 43. So he'd have 43 cards after the first week. That makes sense. And then if we wanted to figure out how many cards he would have after 2 weeks, we could sub in a 2. So 3 times 2 is 6, plus 40 is 46. So it's totally making sense. So sometimes you might want to like sub things into your variables to see if they make sense. And then the restrictions that we have in this question would be the total cards. So there are only 150 Pokemon cards. So therefore, 150 is our restriction for C, the total number of cards. So I could figure out how many weeks it would take him to get that by just subbing 150 in for C. So then if I solved this equation, I'm going to subtract 40 from both sides. So I'm left with 110 equals 3W. And then I have to divide both sides by 3. So W is equal to 36.66666, etc. So it's going to take him almost 37 weeks to collect all those Pokemon cards. So you could say the restriction that you would need to consider when you're graphing the situation, it would be, just scroll down a little bit. I would say the restriction is, if I was creating a graph of this situation and I was putting like number of Pokemon cards here and the weeks down here, whatever you're going up by for cards, once you get to 150 cards, that's where your line has to stop. So if your graph went like this, you wouldn't want to put that arrow on and make it go forever, I guess. You might want to, if you're going to include every value, you might want to like stop it at 150 because that's the max cards he's going to collect. Okay, and for the second question, an airplane is flying at, let's just write our information down, 30,000 feet. It begins its descent at a rate of 5,000 feet per minute. So currently it's at this height. It's its current situation. And then it's going to start descending 5,000 feet per minute. As soon as I see a rate like that, like something per something, I instantly know that's going to be my rate of change or my slope. And basically my initial value or my current situation here is going to be my y-intercept. It's like my initial value. So I can tell that rate just from reading the question. So it says write an equation to represent this situation. So let's that's an L, P.S. looks weird. Let's what would you call it, like altitude? Let's let A represent, or would you just say height? I'm no pilot here. Let A represent the altitude, like how high the plane is. And let's let T represent the time in minutes. And my altitude in feet. So if I was going to write an equation, I could just say that the altitude of the plane is going to be 30,000 is what it's starting at. And then it's descending, so it's going down 5,000 feet per minute. So then we want to subtract 5,000 per minute. So we're going to put a T beside that. Or another way you could write that, if you decided to put, like, you know how we kind of follow this y equals mx plus b equation. So if you wanted to put your rate of change first, it would just look like negative 5,000 t, because your rate of change will be going down, plus 30,000. Makes sense, right? Because if you were to look at the plane, this is like the height of the plane over here, or the altitude, and this is how much time in minutes. So if you're starting at 30,000 feet and you're descending 5,000 feet per minute, that's what your graph would look like, and that's a negative slope. So you got to make sure you include that. And if you decided to like not use A's and T's and everything, and you just went with like y equals negative 5,000 x plus 30,000, it doesn't really matter what variables you use, like x and y's or A's and T's. But I do think it's kind of important to define the variables that you use, especially in a word problem, a real life situation. Okay, then it says, based on the context of the question, are there any restrictions that need to be considered when graphing this situation? And if so, what are they? Well, I would say that you don't want your altitude to go below 0, or, I don't know, your plane would go through the ground. It's going to be kind of weird. So yeah, you would just, when you're graphing it, you just want to make sure you stopped at the x-axis there. Obviously, you wouldn't want to keep it going because that's